Welcome back. So far we have only been reading the raw data from the storage. We've also seen how to apply transformations to that data using select statements. It was great, but from time to time we may want to transform the data and store the results back into the storage. The typical use cases of this scenario are convert data from other formats to columnar file format such as Parquet or Delta so that analytical queries can perform better. In some scenarios, we may also want to remove unwanted columns from the data that we received. This could be due to compliance reasons, for example, to remove personally identifiable information or PII information due to GDPR regulations, or it could even be to reduce storage costs. They may also want to transform semi-structured data such as JSON to rows and columns by flattening the data structure so that it is easier to query and to join with other data. In order to improve the performance of reporting solutions, we can fully aggregate the data and store the results in an external table so that the users of the report can experience lower latency. And finally, we may want to build a traditional data warehouse using facts and dimensions and maintain history within our data as what you can use serverless SQL pool to achieve these use cases. But I would be lying if I said serverless SQL is the best solution for all of these use cases. Serverless SQL Pool does a good job on the top two items on this list, but solutions based on Parquet Pool or dedicated SQL Pool might be a better choice for some of the others. Having said that, we are going to look at using Serverless SQL Pool for these scenarios, and I'll take you through the pros and cons of this approach. Synapse SQL provide create external table as or CTAS statement to achieve the solution for these transformation use cases. If you have worked on other relational databases, you would be familiar with CTAS or create table AS select statements. CTAS works in the same way, but it creates an external table rather than a standard table. That's the only difference. For those of you who are not familiar with CTAS, let me explain how it works. As you know, our aim here is to select some data from the storage and transform that data as required and write back to the storage and also create an external table on the transformed data so that the users can access the transformed data via external tables. As we have seen previously, we can select data from our storage using the open row set function or the database objects such as views or external tables. The select can contain joins, aggregations, and any transformation functions. Once we've selected the data, we may want to write that data back to the same as storage or to a different storage account. On that storage location, we want to create an external table and from previous lessons. You may already know that for external tables, we need to create a data source as well as an external file format. Once the external table is created, the users can access the newly created data via our external table. We can do all of this using the CTAS statement, the create external table. Part of the CTAS statement will specify the external table definition and the external data source and file formats. The select part of the CTAS statement will have the logic to select the data from the storage and any functions and joints. Hope you now understand what the task statement is. Let's now take a look at how the actual statement would look like. It starts with the create external table statement followed by the table name. You can specify the fully qualified table name if you want that to be created in a specific database or schema. The with clause defines the folder part where the files are going to be created. We then have the names of the external data source and the file format for the file being written. At the bottom we have the select statement. Let's take a look at a couple of examples. In this example, we are simply selecting the data from our raw table, which is in the CSV format, and then writing that support case file and creating the external table on the Parquet file. So what we have done is we've transformed the CSV data into Parquet format so that it's efficient for analytical workloads. In this example, we are using open row set function to read the data from a storage and then writing that data back as Parquet file and creating an external table on that. So again, here we've gone from a CSV format to a Parquet format to support it analytical workloads, and also we've created an external table on top. And finally, in this example, we are creating an external table that contains the number of zones in each borough. This is an example where we are studying the aggregated results to the storage. As you can see, you just need a valid select statement and that may contain join aggregations, etc.